Hi grade 8s. So we come to basically the last topic within Algebra 3, which is order of work. Now, fortunately, we've been discussing this the entire time, and so there's nothing particularly new in this topic, but just the questions are a little bit more complicated. Right, so most importantly when we talk about order of work is the things we've spoken about before, and the first thing of that is divide into terms. I know I sound like a stuck record. I don't even know if you understand that reference anymore, but divide into terms is the most important thing that I would have taught you. Then you simplify each term, and then you add like terms. So simplify each term, and then add like terms. Right, so basically those are going to be the 3 steps that we're going to be using throughout this exercise. Now don't forget to push pause, to write down the examples, and to write down all the steps as you go along. Now first example 1, we've probably never seen anything like this before. This is when you have this entire question is one term, but on the top we have 3 terms, and on the bottom we have 1 term. Now our first step is divide into terms, but this entire thing is 1 term if we think about it as a whole. That entire thing is 1 term. And so there aren't any terms to divide it into. It is 1 term. So then our next step would be simplify each term. Well, this is one ginormous term and it says simplify. But if I look at the top, none of those terms in the top in the numerator are like terms. So I'm a bit stuck. I don't actually know how to simplify this. Now this is a very specific type of question which we haven't seen before. When you have more than 1 term at the top and you have 1 term at the bottom, the actual reality is that you cannot simplify until you have 1 term over 1 term. So I'm just going to write myself a little note here. In fractions, this is again probably one of the most important things I will tell you. In fractions, you can never simplify until you have 1 term at the top and 1 term at the bottom. So you may never ever simplify until you have 1 term at the top divided by 1 term at the bottom. Now when we get to grade 9, we learn about a really nifty way to make more than 1 term into 1 term, but we don't get there until grade 9. So what do we do at a grade 8 level when we have this question? Well, I don't know if you remember too much about primary school, but in primary school I think you learned that when you were adding fractions, as long as they all had the same denominator, you could add them. So this entire big numerator actually would have come from 2xy, and he would have had his own denominator of minus 2x. And minus 4x squared is also divided by minus 2x. And plus 6x is also divided by minus 2x. So basically that would have been your primary school logic. Your primary school logic is if you can build the same denominator everywhere, you can keep one denominator. Instead of writing it 3 times, you can write it once and then just have the top. So what I've done now in this step is I've given each term their own denominator. So this is called giving each term their own denominator, because in reality each of these numerator terms has to be divided by minus 2x. So you end up giving each term their own denominator. Now by doing that, you have created 1 term over 1 term for each term. So there are now 3 terms, and each of them are 1 term over 1 term. So now I can start cancelling. Now when you simplify, don't forget whether you're multiplying or dividing, it's signs, numbers, variables. So this first term here, I've got a positive divided by a negative, which will be a negative. 2 goes into itself once. The x's land up cancelling, and I'm left with y. So if I just draw in lightly what I was saying there, the 2 goes into itself once, x goes into itself once, and I'm just left with the y. Now if you are going to cancel like that, try and do it very lightly so the person marking your work can see what your logic was before you scribbled everything. Right, our next term, we have a negative divided by a negative is a positive. 4 divided by 2 is 2. And if I have 2 x's on top and 1 at the bottom, I'm left with 1 at the top. Lastly, a positive divided by a negative is a negative. 6 divided by 2 is 3. And x goes into itself once, so it disappears. And so I've landed up with 3 simplified terms. Now, that's a very specific type of question. We've never seen something like that before. It comes up every now and again. Most important thing from this question is that you can only simplify when there's one term over one term. So if there's multiple terms on the top, you have to give each term on the top their own denominator, and then you can continue as usual. Right, let's try the next one. Next one, first step always, divide into terms. So we've been saying this for a while now, so hopefully it becomes second nature to you. There are 3 terms in this question, so now all I need to do is I need to simplify each term. So I just need to go from left to right, and each term, whatever needs to be simplified, I need to do that. So in my first question, note this is one term over one term, so I can simplify. 9 divided by 3 is 3. 2 x's on the top and 1 at the bottom leaves me 1 at the top, and there's a y at the top. So that's my first term simplified. My second term is a case of distribution. So minus times a minus is a plus. Numbers is 3, letters is x times y. Remember, we prefer to write alphabetical. Then a minus times a plus is a minus 4y. And my last term, there was nothing to simplify with it, so it's plus 5y. And now that I've simplified each term, I need to add my like terms. Now remembering that terms are only like if they have exactly the same variables with exactly the same exponents. So 3xy plus 3xy will give me 6xy's, and minus 4y plus 5y, 5 take away 4 is 1. So either plus 1y or you can just say y. And those aren't like terms with each other, so that's as good as it can get. Okay, now I'm not going to write down those 3 steps again because it's exactly the same 3 steps every time. So first step, divide into terms. Second step, simplify each term. So if I look at the first term, a positive divided by a negative, signs is negative. 16 divided by 4 is 4. Signs, numbers, variables, 3 x's at the top, 2 at the bottom, leave me 1 at the top. 6 y's at the top, 3 at the bottom, leave me 3 at the top. So that's my first term done. Second term, distribution, minus times a plus is a minus, x times x is x squared, y. Negative times a positive is a negative 5, x, and y squared will make y cubed. And then finally, plus 4x squared y. So simplify each term. Done. Next step, add like terms. So these are xy cubed and these are xy cubed. So that's minus 9 xy cubed. Notice, remember, my exponents don't change because I'm just adding like terms. And minus x squared y plus 4x squared y. Well, 4 take away 1 is 3. So it's 3x squared y. So it's nothing different to what we've been doing. It's just that these questions look a little bit more tricky because there's exponents everywhere and complicated terms. But they're all not particularly bad. Right, divide into terms. Simplify each term. Let's look at the first term. Oh, now this gets a bit tricky. Can I multiply the 2 into the bracket first? And the answer is no. Because who does this squared belong to? It only belongs to the bracket. So if I put the 2 in first and I make it 6y and then square it, you're actually squaring the 2 as well, which I'm not allowed to do. So I'm first going to keep my 2 outside and I'm first going to square. So 3 squared is 9 and y squared. Okay, so I haven't actually simplified that term fully yet. Now distribution, minus 3y squared plus xy. And my last term, signs, positive divided by negative is a negative, so I'm simplifying those two. And then 5, one of your x's will cancel, so I'm left with xy. So still not quite simplified, so this is 18y squared and then the rest is simplified. So that's minus 3y squared plus xy minus 5xy. And now that they're each simplified, I can add my like terms. So 18y squared, take away 3y squared, is 15y squared. And xy, take away 5xy, is minus 4xy. Right, excellent. Moving on. Same 3 steps. Divide into terms. There are 2 terms here. Let's simplify our first term. Distribution minus 3a cubed minus 2a squared b plus a squared c. So that was distribution. Now again, look at my next term. I first need to do my fourth law of exponents, which is distributing that exponent. So that is 4a squared. And then I still need to multiply by 3a. So that fourth term now, what is now a fourth term, is still not simplified. So my first 3 terms are actually simplified, and my fourth term isn't. So I still have my minus 3a cubed, my minus 2a squared b, my plus a squared c. But this last term now needs to be simplified. And 4 times 3 is 12, and that's a cubed. So sometimes it takes 2 or more steps to simplify a term. Right, like terms, minus 3a cubed plus 12. Well, 12 take away 3 is 9, so it's 9a cubed. And the next 2 terms are not like. So minus 2a squared b and plus a squared c are not like terms. And so they just are left alone. Right, going on to f. Same couple of steps. Divide into terms. Okay, now f was chosen because if you notice, I need to square everything in the bracket. But we've discussed this before in exponents. Wouldn't it make sense to first simplify what's in that bracket so I don't have to square everything? So let us simplify the bracket. A positive divided by negative is a negative. 12 divided by 2 is 6, and I'm left with 2 x's at the top. Now that's much easier to square. Now if I look at my second term, I can actually simplify this all together. A positive times a negative is a negative. 4 times 2 is 8. X cubed times x would be x to the power of 4. And then last term is plus 10x. So I still need to simplify that first term further. Now just be careful, this means I'm squaring negative 6. And so negative 6 times negative 6 is positive 36. When I raise a power to another power, I multiply. So that's still 3 and 4 of exponents coming in there. Then minus 8x to the power of 4, that looks like a like term with that first term. And then the plus 10x looks like an unlike term with the others. So lastly, I'm going to add my first 2 terms together because they're like terms. 36 take away 8, as far as I know, is 28. X to the power of 4. And my plus 10x is just hanging along at the end. It's not a like term with anything. Alright, so last 2 examples. Again, these are all the same. It's just slight differences and subtleties here and there which we have to contend with. So, divide into terms. Now, this is a particularly interesting question because this first term here, you'll notice, is what we did in A. There are 2 terms at the top and there is 1 at the bottom. Now, I cannot simplify if there's 2 terms at the top. So what I have to do is I have to split up this numerator and I have to share out, I have to give this denominator to every term at the top. So each of those terms at the top get that. So notice I've split it into 2 terms because each term gets its own denominator. Now, this second term, I can actually simplify because I can multiply in, so that's plus 2x squared y minus 4xy squared, and then my last term, there's nothing to do, so he's minus 5x squared y. So I haven't finished simplifying each term because these first 2 terms are not yet simplified, but now that they're 1 term over 1 term, I can go and simplify them. So a negative divided by negative is a positive. 3x, only one x left, and a y. And negative divided by negative is a positive. 2, and there's only one x left. And now I have plus 2x squared y minus 4xy squared and minus 5x squared y. Now if I have a look at this, there's a whole bunch of x's and y's everywhere. Are there any like terms? Well, here's an x squared y and here's an x squared y, but the rest are not like terms. So my 3xy and my 2x and this minus 4xy squared are not like terms with anything. So the only thing that are like is 2 take away 5 is minus 3x squared y's. So don't always expect your answer to boil down to this neat little package. Sometimes it looks a little bit messy like it does there. Now both G and H are ridiculously complicated questions. So I wouldn't overly stress at all in this example if G and H kind of freak you out a bit. I'm not too sure my grade 9s would be able to do this. So they are incredibly difficult, and it's not what we focus on in tests and exams. These are just more like extension questions. So divide into terms. Now this one's particularly mean because look at this top. There's kind of one term at the top, but there's lots of things. So personally, I would distribute in my 3xy first. So I'm going to get minus 12x squared y's minus 6x squared y's. Now as I wrote that, I was like, hang on, those are like terms. Now why are they like terms? Because actually, could I have not just simplified that? I was doing distribution, but I could have just seen that and gone, hang on, those are like terms. So I might be making my life a little bit more tricky here, over minus 6. So in my next line, can I immediately go add those two like terms? That's minus 18x squared y's over minus 6. Now, if I'd noticed they were like terms, I could have simplified in the bracket first, and I would have got minus 6x's. And then when I multiplied together, I would have got minus 18x squared y's. So I would have got to the same place. Right, on to my next term, minus 8x cubed plus 12x squared y's, and then plus 3x at the end. So I'm just going to bring down those. This is minus 8x cubed. There's no like terms here. Plus 12x squared y's plus 3x. So I still need to simplify that first term. So negative divided by negative is a positive. 18 divided by 6 is 3x squared y's. And then minus 8x cubed plus, oh gosh, x squared y's. Now x squared y's mean that it's x squared y's must be a like term with x squared y's. So 3 plus 12 is 15x squared y's. But the other two are not like terms with anything. So minus 8x cubed plus 3x. Now let me just say this again. G and H are considered really, really horrible questions. So when you go to the mixed exercises and you go look at past tests, the chances of you seeing something like G and H are quite small because they really, really are unnecessarily complicated. But it's nice to be extended and just see one or two really big ones. Right, so that's the lesson on order of work, and really that pulls everything we've pretty much done in the whole of term 1 in terms of algebra together. So what you need to do now is exercise 4 is our classwork. I will post it as a PDF on Google Classroom as well. And this is pretty much our last thing in Algebra 3. Once you've done this and marked it from the memo, we're going to head on in the next lesson to a mixed past paper from Algebra 3 and Algebra 2 and Algebra 1 kind of all mixed together. And then that'll really tell us how well we know algebra. So well done, guys. You're almost finished.